Welcome to the Explainer. Today we're diving into a tool that, well, it kind of helps us see the future. I'm serious. It's called a discrete probability distribution, and it's all about moving past just guessing and starting to make some really smart, calculated predictions about everything around us. So let's jump right in.
Okay, so picture this. You're running a coffee shop. People are coming in and out all day long. How on earth can you predict what they're going to do? Let's get specific. Out of the next 10 people who walk up to the counter, how many are going to pay with a debit card? I mean, we could just throw out a number, right? Take a wild guess. But what if we could actually map out every single possibility and see which ones are the most likely to happen? Well, that's exactly what we're going to do.
All right, but before we can start predicting anything, we've got to get the basic building blocks down. So this first part is all about the tools we need to start counting up all those possible futures.
First up is something called a random variable. Now I know, it sounds super technical, maybe a little intimidating, but trust me, it's not. All it is a number that we attach to a random outcome. So back in our coffee shop, our random variable is just the number of people who pay with debit. It could be 0, maybe it's 1, maybe 2, all the way up to 10.
Now, this is a really important distinction. The number of customers we're talking about is what's called a discrete variable. Why? Because you can count it. 1 customer, 2 customers, 3 customers. You get the idea. You can't have half a customer, right? That's totally different from a continuous variable. Something like, say, the time it takes to fly from Orlando to San Diego. That's something you measure, and it could be anything. 4 hours, 4.5 hours, 4.673 hours. See the difference? For what we're doing today, we are laser focused on those countable, discrete things.
Okay, so once we know all the possible outcomes, we can build what's called a probability distribution. And a great way to think about this is like a menu of the future. Seriously, it lists every single possibility, from 0 people using debit all the way up to 10. And next to each one, it tells you the exact probability of it happening. This is basically our roadmap for dealing with the unknown.
So for a problem exactly like our coffee shop one, we are in luck. Big time. We don't have to build this whole map from the ground up. Nope. There's actually a special tool that does all the heavy lifting for us.
And that amazing tool is the binomial probability distribution. It is absolutely the hero of our story today. Think of it as a pre-made formula that's just perfect for situations where you're doing the same thing over and over and there are only 2 possible outcomes each time. But, like any superpower, you've got to follow the rules.
And here they are, the 4 rules. I like to think of them as the ingredients for a recipe. If you have all 4, you can make it work. First, each trial, so in our case, each customer, can only have 2 outcomes. They either pay with debit or they don't. Simple. Second, you need a fixed number of trials. We've got that. 10 customers. Check. Third, the probability of a success has to stay the same for every single trial. That means the chance that any given customer uses debit has to be constant. And finally, number 4, the trials have to be independent. What the first customer does has 0 effect on what the second one does, and so on. If your problem checks all 4 of these boxes, boom, you can use the binomial distribution.
And you know what? Our coffee shop problem, it checks every single box. It's a perfect fit. So let's put this hero tool to work and finally answer that question from the beginning.
Okay, here's the setup. We look at the data, and we know that about 28% of coffee shop purchases are made with a debit card. So the probability of success, which in statistics we call pi, is 0.28. And the number of trials, or n, is our 10 customers. That's it. With just those 2 little numbers, we can generate the entire probability distribution.
And here it is. This is our complete map of the future. Look at this. What's the probability that none of the 10 customers use a debit card? Well, it's about 3.5%. What about the chance that exactly 1 person does? That's up to 13.6%. This table, it just lays it all out for us, the likelihood of every single possible outcome, all thanks to that binomial distribution.
So take a look. Where do the probabilities get highest? Right there. The single most likely thing to happen is that 3 customers use debit. That's got a 27.6% chance. And right behind it is 2 customers at about 24.8%. So if you had to bet, you'd bet on either 2 or 3 people using a debit card. And just like that, we've answered our question, not with a guess, but with a real data-driven prediction.
But this distribution doesn't just tell us what's most likely. It's also really good at telling us what's unlikely. So check out this number, 3.4%. What's it all about?
Well, that tiny 3.4%, that's the chance of seeing 6 or 7 or 8 or 9 or even all 10 customers use a debit card all added together. So is it possible you'll get a huge rush of debit users? Yeah, it's possible. But is it likely? No way. It's highly improbable. And that's the kind of insight that helps a business plan for reality, not just for wild guesses. So let's zoom out. Why does any of this really matter? Because what we've been doing here, it's not just some abstract math problem. It's a whole new way of thinking about the future. It's so important to remember this. The binomial distribution is not a crystal ball. It's not going to tell you that exactly 3 customers will use debit tomorrow. That's not how it works. What it does is give you a really clear mathematical picture of what's probable and what's not. It takes you from a fuzzy guess to a sharp, structured understanding of risk. And once you start looking for it, you see this kind of thinking everywhere. Quality control in a factory, they're using it to predict effective products. Medical trials, it's how they figure out the success rate of a new drug. Marketing campaigns, election polling, you name it. The underlying logic is exactly the same.
You know, this reminds me of this powerful essay by the scientist Stephen Jay Gould. He was diagnosed with a very serious illness and was told the median survival time was just 8 months. 8 months. But he was a statistician, and he knew that one single number, an average, a median, almost never tells the whole story.
So he went and looked at the full distribution, the whole map, and he saw that it was heavily skewed. What that meant was that while half the people lived less than 8 months, the other half had a long tail of possibilities. Many, many people lived much, much longer. He ended up living for another 20 years. It's such a powerful lesson. A single number can be so misleading, but a distribution, that gives us the full story, all the nuance. It gives us the power to see the entire range of what's possible. So I'll leave you with this question. What parts of your world, your job, your life, could you understand better if you stopped looking for a single guess and started looking for the full map of the future?